All right, everybody. Welcome to the adventures in AI in JavaScript. We're going to talk today a bit about machine learning in JavaScript, which I think is a pretty exciting and new frontier for AI. If you are new to AI or machine learning, then you should be able to get a lot out of this. If you and most people here at the conference are already pretty experienced with AI, but not so much with the aspect of applying this to JavaScript, then I think that you'll get a lot out of this from that perspective. If you're coming to it saying, well, I know about machine learning, what's the advantage here to throwing in another programming language? I think that what's really cool about this is we will cover some exciting applications, usage, and sort of demystify that aspect of JavaScript being a complication to this new medium rather than being advantageous to it. So let's get started here. First of all, I'd like to say why you should listen to me for a moment. Number one, I am the chief innovation officer of a company called Infinite Red. We're a consultancy where we apply mobile and web and AI related tasks for businesses and products. And as the innovation officer, it's sort of my job to make sure that I'm on the cutting edge of using technologies that give our clients the max bang for buck and let them all sort of enjoy this new avenue of technology as we come into it. Additionally, I am a React Native core contributor, so I've built tons of React Native apps. I think that it's been pretty amazing that we have iOS and Android and Windows and Mac, and here we are using JavaScript to deploy to each of those. So the ubiquitous nature of React Native as well as JavaScript sort of being on all these different platforms can come serve us as well if we can get AI to perform in it. There's the difficulty that we all have to figure out. And then lastly, I'm a Google developer expert in web and machine learning. GDE, not GED. I've been a developer for 20 years, so it's a pretty exciting avenue. But being a Google developer expert in web and machine learning, what more perfect way to sort of unite the idea of AI and JavaScript with these two technologies and using things like Brain JS and TensorFlow JS to go ahead and build something that we could sort of take all of the products and bring them to the next level. So I am excited to talk about all of this, and I think that for you, if you've never heard of me, go follow me on Twitter right now. I promise you, I will have equal exchange of things that are silly, things that are sort of technically minded, and then finally some giveaways. So I will be giving away some really cool stuff when this airs. So go follow me on Twitter right now, and one of you will be selected to go ahead and win something exciting at the end of this talk. So if you're looking around, I have a bunch of really silly icons, which I find quite entertaining. So if you want some stickers, or if you see these on GitHub or LinkedIn, yep, that's me. All right, so we're here talking about AI. And for those of you new here, AI is a huge umbrella term. And the aspect of using AI in JavaScript is just programming for the longest time. But in this new avenue, since 2012 and ImageNet results have started to creep up into human-like and superhuman-like capabilities, there's this whole advent of the idea of, you know, neural networks. And neural networks, coming from this other aspect, allow us to sort of solve that problem. I don't know if you've seen the XKCD, where they have a person says, "Oh, we need to know if this photo was taken in a park." No problem. You know, you will use their GPS. "Oh, and I need to know if the photo has a bird in it." And then the person says, "I need 5 years in a research team." Right? Well, now it's quite trivial to identify if a photo has a bird in it. This is the cool thing that we've gotten here with neural networks. And with this new avenue of technology, it's only a matter of time before that sort of extends into um, all these other platforms. And I think that that's the cool part. Is I want to talk a bit about machine learning. I want to talk about neural networks and how they are working inside of this particular structure, which is specifically I want to talk about how to get the same sort of performance that you're seeing in all these products to happen in JavaScript. So, with that being said, I think it's pretty clear on why we're looking at machine learning. If you're new to machine learning and you're actually watching this talk, I would say that the beauty here is that we get this write once, use anywhere kind of technology. And as web developers who have built the same thing time and time and time again, um, I think that's the draw to microservices. I think that this is what the draw is to machine learning. The idea that we can set up a framework and train the language objects and sound in a generalizable way that can solve these problems. How many times do we have to load up a static website, right? So bringing AI to JavaScript and to web and to the edge devices is going to empower our technology in a super cool new way. So to sum that up for a little bit here, why machine learning? For the power, right? We want the power of machine learning to be applied in this, and we're not the only ones. Google's been shoving machine learning into everything for a while now. At the end of 2017, they had over 4,000 TensorFlow machine models in production, and they had fewer than 4 at 2012, right? So I think that everybody's seeing the value here of how do we get AI into all these nooks and crannies and corners. So, on aspects of what machine learning currently does, I think it's exciting that we can come up with a new algorithm to identify what the next product you should buy is. And that can boost revenue sales greatly. But of course, the web is interested in, deep fakes and having fun stuff happen there. But regardless of web being that aspect, uh, we're seeing it severely with product sales. And where are product sales? Product sales are on websites. So you might have seen this in CES 2018, where a person's trying out different types of hair dye before she actually has to dye her hair. This sort of like concept of tying in with sales is both graphically pleasing as well as ambitiously amazing. And so we actually had a client come to us, I want to say in 2018, looking to go ahead and do makeup transfer directly in the browser using WebAssembly with their model. And the idea is that once they've tried on this makeup, they can click the purchase button and receive exactly those items that they are looking to actually buy. Here's our dev working late into the night, virtually trying on some makeup. He seemed to enjoy this quite a bit, but it's a really cool idea here, and I think that's the exciting part of this is that we're finding ways to go ahead and sell this out there. For instance, there's additionally people are selling noise cancellation and tying all those other aspects in. The list of abilities that we are able to do here is growing substantially. And I threw in some examples besides Crisp AI, which is the noise canceller right here. For the new people, those of you who are familiar with machine learning are already quite sure of all the things that it can do. But we can have it generate new heavy metal music. We can there's YouTube channels and websites where people are listening to generated on the fly heavy metal right now. And if you download these slides and you click on this picture, it'll take you to that YouTube channel. I can't tell the difference between AI generated heavy metal and actual heavy metal, so I'll leave that to the experts. But websites are already benefiting from this sort of immediately generated. And as you know, OpenAI has an entire SoundCloud account with songs that they're generating in specific styles and setups. Google leaned into this pretty early with QuickDraw at quickdraw.withgoogle.com, where actually using people to give the data directly in a website. And for data capture, in this world, people are eager to actually give data for machine learning. The QuickDraw datasets, 10 million drawn images that have been curated and selected. So if you wanted to have Pictionary tomorrow, and you wanted the data set for that, that's free from this website. But that was originally asking people to kind of insert that information with JavaScript, with websites, with canvases. And now we've got this information that's available. I believe the current quickdraw.withgoogle.com is a little bit of a game, now that's all collected, where you draw something and it tries to identify what it is you're drawing based off of that past data. So now it's just living in the browser doing machine learning. But people are also using this for recoloration of photos, and then of course push it to the edge. We could put this on Raspberry Pi devices as well. So we could put this on the out there to identify when your parking spot is finally available, so that you can jump in there and get a hold of it. And this is the power of the edge devices, right? And this is the power of JavaScript. You have this client server architecture and this real time GraphQL subscription system that allows you to immediately identify things. This sort of interconnected network has always been the sort of strength and the fort of what you've been doing in web and JavaScript overall. So why aren't we leaning into this with AI and machine learning? I think that this is key. For those of you who are new, and the some of the terminology that I've used here is a little bit confusing, don't worry. I actually have a 100% free course at academy.infinite.red called Demystifying AI. It comes with a 5-day certificate to let you know that you've got the terminology on it. So if you're experienced in AI machine learning at this conference and someone keeps asking you about basic terminology, send them to academy.infinite.red and have them take the AI Demystified course. It'll give them that basic buzzwords. It's a lot of fun. I spent a lot of time working on this, and people said, hey, we really enjoy this online course. Now, of course, everybody's going to say that everybody enjoys their online course, but just to prove it to you all, I went ahead and asked AI to prove it here. So I got the TensorFlow JS sentiment analysis model, took all of the comments of the I think by the time this airs, we'll probably have 5,000 students in there, and just got their comments and then ran the sentiment analysis to see what the scores were and checked it out. And people are very happy with the course. AI has proven it. As you can see in the sentiment analysis, those low scores are a little bit mistakes of people sort of like answering questions for one another. But yeah, it's a really fun aspect. And I did all of this in a browser. It wasn't hard at all. But I don't want to come off as too inhuman. So I will say, come check out the course. Please leave a comment. I promise you, I read these every morning. It's in my emails with coffee. So you could definitely check it out. Don't worry, it's not sitting there alone without anything happening. So I want you to know it's a fun aspect of what I do. Now, those of you who are into what AI should do, there's no limit to the advantage there. But I think that this interconnective network that we're looking at with web and JavaScript is key. So, what exactly is going on with the machine learning setup? Like we're saying here, like what's happening with this? Um, And it's no different than what you do if you are a Python or a data scientist, the entire training, the entire setup that you've done, you can actually still get your model trained in, let's say you train in TensorFlow. Well, um, if you are training in TensorFlow and you're a master at Python, you can still do all that code and then convert it over to a front friendly model with the TensorFlow JS converter. And then you might say to yourself, well, why would I convert it over? I'll just use Python, I'll use Django, I'll just keep this on the server. Well, the truth is that one of the great things about JavaScript is it can be client friendly. It can run on their machine. And so, my advanced people and my newbies along the way, we've always got these server side processes that sit there and they can get clogged up. I believe there was a website that's like, turn me into an anime character. The model was living on the server. So more and more people were hitting it, and the queue was getting filled up, and then it was overflowing. So they had to have these really nasty messages that said, we're sorry, please come back. We'll convert your image to an anime character. And I think even AI Dungeon, if you've checked that out, had some of this problem as well. AI Dungeon needed funding because the server costs were starting to add up. What if you front load that model? What if the model is actually not running on the server, but it's running on the clients right there on the front side? And the speed for the inference is depending on their GPU. It's depending on their setup and their computer. Well, this frees you from this normal inability. This is what we're talking about. JavaScript allows us to take the model and apply it all the way to the edge. This is like what we're doing on mobile. This is what we're doing where we're kind of pushing things towards TensorFlow Lite. And so I think that like this is the exciting part of JavaScript is that the model is this key aspect that can be where you want it to be. Do you want it to be on the server or do you want it to be on the client? Do you want some kind of mix? Do you want to do some inference and then have that be mixed in over on the server? Are you looking at federated learning? So there's these really cool aspects to this that I think are opened up by sort of accepting machine learning in JavaScript. The other key thing here is I want to say those of you who are coming into this and you're unfamiliar with AI, unfamiliar with these terminologies, as a web developer, it's not that hard for us to understand models because a model is just basically a function. And taught specifically that way, any web developer can handle the idea of a model. Where's that function running? Is it running on the server or is it running on the client? And the fact that we still call this a model, I understand all of us who finished, Andrew Ng's Stanford course want to keep the terminology that sort of like pressed upon us. But the truth is, let's just say it: we've got data in, like people's faces, and then we have data out, which is like their actual sentiment or their assumed um, age or whether or not they're actually a human being or what they are. And that's a function. That's a function, right? So, to a certain degree, we are bridging the gap between product and actual development and people who are bringing these services to the edge and being able to apply them and the mathematical concepts that keep this graph model properly tuned for us as well. So I would say that we've sort of like broken through that. We can call it a model, we can call it a function. I know that might be driving someone out there with a PhD absolutely mad, but I think that we can really kind of call these things the same thing, and we can argue in academia after everybody's actually kind of using this kind of information. So, where do we get these models from? Well, we can get these models. Like I said, you can train them in Python. You could train them additionally, and you could use Onyx to switch them over and then bring them to TensorFlow.js or re-implement them on top of Brain.js. The idea of actually these models being trained in your stalwart, your strengths, and then kind of converted over to be JavaScript is quite doable. And that's the cool aspect of all this stuff. So I would say that we have this idea that there's a disconnect, right? That you can't have Python mixed with JavaScript, mixed with this and that. But at the same time, we're kind of already mixing those things already. As of right now, these large companies are sort of pushing for server side dependence, which is fantastic, and you can kind of use those. These are all links if you click on them. It's the AI services of Amazon, Microsoft, and Google. And sure, these come back with really cool results. But when we're pushing all of these things out of their original domain, we're essentially identifying server only microservices. And I think that, kind of we have this advantage where we don't have to do that. We can actually have um, the machines themselves actually run the JavaScript and actually deal with it and then send the result back to us. I have a demo that I'm going to be doing of exactly that, where we will have hundreds of models running on hundreds of browsers, and then the results will be kind of sent back and then summarized in my Amplified Days talk, which is coming up. And that's a free conference. So if you check me out at Amplify Days, I will show you a live demo of doing this in browsers with JavaScript. But that's the magic that we can get here. Now, you're constantly going to get this question, right? Isn't JavaScript just a toy language? If you haven't, maybe you've got CUDA set up and you are just tearing things up on your machine, or so Linux, or you've got a machine that's ready to train on and work with. Well, that's fine. But when you actually need to implement these things on the edge, you're like, oh, well, this is going to slow down the machine. But JavaScript's not a toy language. As a matter of fact, through WebGL, we can access the GPU. Both Brain and TensorFlow JS are, I think Brain might be finishing that up, but they use GPU JS, and TensorFlow JS uses WebGL to identify and actually access the GPU on that actual individual machine. And that's the cool aspect. You're getting significant real-time inference for these models in the browser. It's not a toy language. You can actually work with those immediately. So I'd say with JavaScript, you have TensorFlow JS, which of course is supported by Google and is pretty platform independent. I wish that I could speak to the PyTorch equivalent of that, but from what I've seen, Google's significantly investing in TensorFlow JS, and they're actually bringing in straight up WebAssembly support, so that way, which might be the standard there for a bit, because the WebAssembly has been quite consistent and near GPU like capabilities in that handoff, and I think it's going to pass everything up. But if you are, I will not work with Google stuff, then you can always go with Brain.js, aka Brain. And then last but not least, if you want to come around from the native side, specifically on devices, or if you want to do it on Windows or Mac, you can use React Native, which is platform independent, which can always tie down to the native level. So JavaScript will get you to all of these places. And I've done it for React Native to show this demo several times. Here I am using TensorFlow Lite to do simple image recognition. Of course, the taco is not in this data set, so when I click on that, it thinks it's a pencil box. My apologies for that, but it's pretty fun. When you click on that link right there, it'll bring you to the code. So that is JavaScript tying directly in with TensorFlow Lite to get the optimization on the phone. And here we are with just purely Brain.js, which is going to state in JavaScript using the classic MNIST problem on the phone as well. And then here we are going into Core ML, tying directly into, on the other side, on an iOS device, tunneling directly into the path using JavaScript again to go ahead and use the Food 101 data set and the Food 101 model to essentially make hot dog, not hot dog on a mobile phone again. So entertaining, interesting. Are we able to make JavaScript do what we want it to do? Resoundingly, yes. I've not hit any kind of limitation on that. So let's stop talking about limitation for a moment here, and let's start talking about opportunity. For a talk I did in 2018, I did a very fun and interesting sort of intro for developers into AI. And I've built a website called nickornot.com, which identifies the age-old question, is Nicolas Cage in this photo? And you can go to nickornot.com and you can actually upload photos and it will identify whether Nicolas Cage is in the photo or not. And this is done with TensorFlow JS on top of Face API directly in the browser. I also made declarationofindependencethief.com, which has a different styled model, which I used for a mobile device. It's quite entertaining, the stuff that we could do. But here I am, basically accessing this on the website directly. And we also can do Chrome plugins because we're JavaScript, right? So a friend of mine, Chris Beekler, had seen one of my talks, and he was on the JavaScript Jobber podcast. He knew nothing about AI. And he said, Gant, can we build a Chrome plugin? Or actually, can we build this idea I have? And I said, absolutely. That's a great idea, and we can build it. By the way, sorry about that. That's an old photo of me. I said, yeah, absolutely. Let's build a Chrome plugin. So we're using JavaScript, and now we've got an in-browser cross-website capability. And his idea was, so we live in the States, and he was sick of seeing our president. And I'm not going to get political on here at all, but he said, I don't want to stop reading the news. I just want to stop seeing the president. And I said, that's easy enough to do. So he and I teamed up and we built a website, notrumpsocial.com, which puts a browser plugin so that you can identify specifically when you're going to Twitter or Facebook, if it sees Trump, it converts him to a puppy. So this Chrome plugin will take pictures of the U.S. president and then turn him into pictures of a puppy. So that way you don't have to look at him nearly as much. And this is just an example of sort of like that radical capabilities of being able to build something both, again, in my nature, fun and interesting, but also quite powerful directly in the browser. So with this aspect, I think that one of the cool things that comes out of this is that JavaScript developers don't actually have to know about AI in order to go ahead and use it. So we have this other project that I want to show you called Not Safe for Work JS. Not Safe for Work JS is a content indecency checker. There's a great opportunity because most of the time, lots of companies have thousands of people to check indecent content. Those people are going through messages, which can violate privacy. And of course, people can be very inconsistent on saying what is and isn't supposed to be available. So when AI does it, at least it'll be consistent with saying the same thing every time with reproducible results, where a human won't, and a human won't be privacy, and humans cost money. So we decided to go ahead and wrap this up in a way that a non-AI developer could use. And we decided to make it 100% free. So if you're familiar with JavaScript development, you're familiar with Node Package Manager, which has been acquired, now part of GitHub and therefore Microsoft. But what happens is if there's some code out there that you specifically want to run, you add the package to your code. Well, in machine learning, it requires quite a bit. Understands that you have to understand how a model works and how these other aspects work. You have to understand tensors. You have to understand, um, images and like essentially what the results coming back are. Maybe you even have to kind of like understand softmax, to a certain degree. Like I wanted to hide all of that, and with not safe for work JS, you can. You just install NSFW JS, and then you can immediately give it an image, give it a canvas, give it an HTML element, and then it will run that and then identify whether or not it thinks that there's a indecent content right there on the client. So you could build this into all kinds of stuff. This could stop someone from uploading something, or it could be inside of messaging between two people for a conference, perhaps, helping your code of conduct. It could blur out an image so that way when the image comes through, it'll say, we're 95% sure you should not unblur this image. And then the person can make their absolute adult choice. So we built this, and people are using it. It's got 3,700 stars last time I checked. I can't remember. But it's got thousands of stars, and people who know nothing about AI are able to use this because it's been wrapped up in JavaScript, and it is now in websites, both server and client side. And that's the power of what I'm talking about. I think what's really exciting as we're applying AI and machine learning directly to the advantages of having JavaScript. So a little bit more about Not Safe for Work JS is here's a fun kind of aspect. As I'm not brave enough to do a live demo, you can go to nsfwjs.com and do your own live demos. But yeah, we can kind of check it out. You could drag over images from the test sets. Now you might notice that I have Jeff Goldblum .png on the right side. And the reason is because when I originally trained this model, for whatever reason, it identified Jeff Goldblum as pornographic. To be fair, Jeff Goldblum is a handsome person and does have a ridiculous number of images where he's touching his face. But here's the cool thing that happened because this was community driven, because this was JavaScript driven, because this was open source. People helped identify this problem, and the bias in the model was identified and then brought back, and I was able to fix it. So yeah, now Jeff Goldblum is no longer identified as pornographic, which of course makes us all a little bit sad. But that was because people were using it. That was because people are capable of dragging an image over instantly. The onboarding process has been minimized, and that let me create a better open source model. Since then, quite a few other people have jumped in and helped improve the model, and it continues to improve as different technology continues to improve. So thanks so much to the community on that. This is something we gave the community and they gave back. It's easy to do when it's JavaScript. So I'll say that specifically, yep, it's still biased, and of course, everybody can still work on making it better. But let's take a look. The idea of training in a browser feels a little bit alien, and I'm sure that people are like, I'm not sure how this would even kind of work. So actually, I have a live coding demo, and I'm going to run it with you, and we're going to talk about it. But I'm going to talk about it in a way that both beginners and advanced people will hopefully be able to respect. So let's take a look at this demo. I'm going to click in here and go to the paper, rock, scissors. And this is a website that you can pull up right now. And if you'd like to train along, have a blast. You're not going to take down my server. I'm not even sending you a model. I'm just sending you a website, and you are going to train that model directly on your machine. So we're going to use Lawrence Moroney's rock, paper, scissors dataset, which has this has these 3D animated hands. It's about only 2,600 images, but it's pretty nice. And by the way, so here's a zombie hand throwing rock, and then here's another hand throwing a scissors. And so we're going to use the TensorFlow JS directly to do this. So I'm going to say load and show examples. So now it's loading 10 megabytes of data. And you might be wondering, how are you getting those 10 megabytes of images into your browser? I actually wrote an algorithm to do this as a sprite sheet. So if I click on this sprite sheet right here, you can see the image, and each line is a sort of flattened out version of that. This code's freely available if you want to make your own sprite sheets. You can have fun with all kinds of stuff. Not to mention, you could probably just write this yourself, depending on your level of advancement in Python. So I just created an image, and it's a 10 megabyte image, which loads all the stuff. And then when it's parsed back in, you can see here we have a random selection of hands. Now, this little window that opened up on the side here is called the TensorFlow JS Visor. And isn't this just great? Isn't this just a wonderful experiment? And you can actually build your own components that tie directly into here. What a great way to be able to not only educate, but work with the technology you're checking out. And we can see that all these hands have a really bright white background. This will make it really hard for me to do a live demo for you to have it actually work. Plus, I'm using my webcam to record right now. But if you take a look here, I just created this dataset object, and then the code that I'm loading here is just as simple as data.load. So you can easily pass this off to JavaScript engineers. We're not breaking any kind of new layers here. And this entire website was built with React.js. So I have this cool panel that comes in for free, and I'm going to create a simple model here. So this is somewhat like the MNIST dataset model. I'm going to start off with a convolution, a max pooling, a convolution, a max pooling, and then I'm going to flatten it down to a dense layer. And then ultimately, I will have a soft max with rock, paper, or scissors as the final layer there. But so this is a very simple model. And when you look at that in code, it looks a lot like TensorFlow JS looks a lot like Keras. So it looks like TensorFlow JS 2.0. So you can see here, I'm just simply using a sequential model here to add each layer. And it's very simple, right? I'm writing the convolutions. Here's the max pooling. Here's another convolution. The max pooling, flatten, and then give me a dense. And then, like I said, yeah, look, I'm looking at soft max. And then I'm going to compile this using categorical cross entropy with the metrics of accuracy. And the optimizer I'm going to use is Atom. Okay? This is simple code. So now that I've created this, and I have an advanced model here, which overfits like crazy. So we're not going to use that one. But I'm going to check the untrained model result. So as I click this, I'm going to tell it to go ahead and run my test set through, and then pop out a confusion matrix. Isn't this nice? So we're walking through, and to do the same kind of thing that I'm doing here in Python, we've kind of need we need a notebook, right? We're going to need to go ahead and work through a notebook to see these things. But we're able to create this sort of like high depth experience where we can kind of emulate the same sort of thing that we would get in a notebook, but we're able to also hide as much of this as we want to as well. So if you're familiar with Python and you're kind of getting that same experience, that same feel here, good. So we're checking the untrained model results, and you can see that it thinks quite significantly almost everything is scissors. Despite what actually nothing is paper to this untrained model, right? So let's go ahead and train it real quick. And I'm going to click this right here, and yep, you guessed it. It's going to activate my GPU, pull it up, and here on the visor on the right side, it's going to start sharing that training results with us. We're going to actually, I have it printing out the batch end, and then of course I've got the epoch ends as well. So we can watch as our loss function goes down and our accuracy hopefully goes up. And for those of you who are new to machine learning and AI, we want to see our loss go down. It's an excellent thing, and we want to see, as you might have guessed, the accuracy go up. You might think, what are the difference between these? Go see one of my other talks if you're new at this. I'll happily explain it in that. I'm sort of shooting at the middle here of people being experienced and new at the same time. So as you can see, after 12 epochs, we've got an accuracy of, what is that, 95? Let's see here, yeah. Oh, 93. So we're 93% accurate with this model. So let's go ahead and hit the check model after training. And look, there's a healthy confusion matrix, right? We could see that we're still having a little bit of, most of our problems are still happening in the paper front here, some miscategorizations. But this is a nice healthy confusion matrix, and we can see we've trained this model. So how big is this model existing? So did we train this going off to a server? No. Did we train this directly on our actual on our machine? Yes. If you didn't have GPU or if you weren't recording, would it have gone longer or shorter? Yes. This is a cool aspect of what's going on. We can train directly on each person's machine if we want to, but we don't have to. We can then take that data, whether we trained it in Python or in JavaScript or on a server, and then we could send it over and then instantaneously have a 48 kilobyte model that loads into our page, which is super small and fast, that we'll be able to identify rock, paper, scissors now. Which I think is super cool. What a great thing. You could make an amazing rock, paper, scissors game with something like that. So just because I knew I wouldn't have the ability to show with my webcam, I have some images in here as well. So I'm going to hide our visor over here on the right side. If you want to dig into some of the code, this whole thing's open source, but I also have these little code blocks here showing what the training looks like. And so this is the code that I did for training that right there. So feel free to dig into the code on these. We checked the model after training. So here's rock 100%, paper 100%, and scissors 100%. You can see I pointed this at my ceiling, so that way it would have a white background like it has in the training data. And then you can launch a webcam with the trained model right here in the browser and try it out with your 48 kilobyte model, and it'll show you a little 64 by 64 gray image of what's going on there. I also loaded in a much larger MobileNet advanced one, which has object detection for your hand. This is really cool. Definitely try this one out a little bit as well. And then I think this is really neat. So, wow, here we are. We're live demoing this. I can send you a web page. You're checking it out. And then with these trained models, we can make new applications, new businesses, new ideas of exciting and wild sort of applications of this that scale. And like I said, go see my talk at Amplified Days if you want to see me do a truly scalable, interesting sort of aspect where I'm shipping out hundreds of models to sort of have the set. And here you could easily have two people playing against each other in rock, paper, scissors on their webcam. There are plenty of TensorFlow.js examples out there, so check that out. All right, so back to the presentation here. I'll say that this is where I would like to have you get in there. I would like to have people come up with really exciting, cool ideas, and then apply it to just put it in a website. We've seen the success of what this person does not exist.com and this foot does not exist.com. So this person does not exist.com, where we've got these great ways to generate. Wow, StyleGAN 2 is amazing. So look how beautiful this stuff is. But this is why did this blow up in the industry? Because we can access it, we can touch it, we can check these out instantaneously, and that's the advantage of what we're looking at here. So if you don't have any aspect of JavaScript, you should really consider how entertaining and how rewarding something like this is. I am going to give you a quote: reimagining everything inspires science. And that quote is from a bot, because it's only appropriate that it is. And that bot is inspirabot.me. So if you're looking for inspirational quotes, I suggest that website. If you are brand new to TensorFlow JS or brand new to machine learning and AI in general, I do have a course on how to get started with that. I start very, very fundamental. So if you're a little bit afraid, if you're super advanced, then I'm sure you could teach yourself TensorFlow JS. This is still a great buy. So at academy.infinite.red, you can get my beginning TensorFlow JS course, which I don't think there are any real TensorFlow JS courses out there. There's a really good one by Lawrence Moroney with week 1 in sort of like deploying TensorFlow models. That's a really good one. And I'd say this is really good too. I put up my heart and soul into it. So if you decide to take it, this is my talk code, Gant Talk. It's only for people who have actually seen have seen me talk. Do not give that code out. You could always still take the online course, which I say 3K here. We're nearing 5K now. So the online courses have been growing significantly. And then lastly, I want to kind of appeal to the reason we got into all this. The easy onboarding, the way the speaking to computers really helped out. I have this account called Fun Machine Learn. I think it's really fun and entertaining. It has unfortunately, that's my hashtag. So you can't use that. You just have to go visit it at Fun Machine Learn, or follow me on aifyi.com, which is my newsletter where I say really cool and interesting things that have come out. And hopefully you can kind of check those out as well. Thank you so much to Infant Red for letting me be their CIO, letting me kind of investigate and be their mad scientist. If you ever see me at a conference, ask me for a sticker. Like I said, I have tons of cool, different, amazing stickers. I'll even be giving some away. So follow me on Twitter, and I will give away stickers, courses, cool stuff here and there. Check it out. And thank you so much for listening and kind of letting me rant a bit about how awesome it is that we're coming together with AI in JavaScript. Thank you very much.